Hello everyone, welcome to our first full-length video in our Fusion Zero to Hero series, where today we're going to be looking at modeling. So we're going to be taking a look right from the ground up, how to model two different components. So for our first video, we're just going to be looking at the modeling process, the different tools that are available to us to go from sketch, from concept, to get to a semi-finished product. And then in our next video, we're going to be taking a look at how we can begin to tie down some of those dimensions using some of the parametric modeling functionality and a few other elements to it. So today's video, we're just going to be looking at the modeling aspects that are available to us and see how we can quickly go from nothing through sketching into the full-on phase from there. So without any further ado, I'm going to go ahead straight into it. So in the Fusion interface, I'm just going to go in and create a brand new document. Just hit a little plus icon to the side over here, or we could hit File and New Design. This is going to create a brand new document or brand new part or file within the interface that we can then begin to work in. So we're going to start off with the propeller itself, or the turbine itself, where we want to create this component on, or at least a lot of the detailing, just to simplify things. We're going to just do a lot of the detailing of the propeller itself on a single sketch. So I'm going to start off with a 2D sketch. We always wanted to begin by starting with the 2D geometry that we want to then bring in. Unless we have the parameters, we might want to go and place down parameters first. But for the sake of this one, we're just going to start with a 2D sketch. I'm going to be using the side or the front plane to design this from, because I'm going to be designing from the front, but obviously choosing whichever plane you find relevant for the model that you're creating in that aspect. So the first things we're going to take a look at, if I have a look at the component that I've kind of tested this on, we want to obviously have a bit of a thickness to the bottom edge of the root of the turbine itself. So we want to be able to have that little bit of thickness there. We also then need to establish a height, and then we want to be able to have two separate profiles for the root of the impeller itself, as well as then we want to, in the same sketch, be able to determine the shape of the blades themselves. So by simply going in and adding in our lines, I'm going to start with the line tool up at the top left and start from the origin. Always want to try and model as close to the origin as we can, or at least for dimensioning purposes and that as well. In components, we want to be modeling around the origin. So I'm going to go with the first line straight out from there. To an amount. I'm not too worried in this phase. It's a conceptual phase at the moment, so just going to be placing out a few dimensions, more or less to the extent of the outer part over there. And I'll go straight up from there to create that little bit of a thickness towards the bottom of the part, and then I'll come in with a spline of some sort along the way. But for now, I'm going to hit escape to finish that line off, and then pretty much do a similar process on the top half of the component. So going straight up for the vertical edges of the part, going straight up by, again, an amount. I'm not going to determine exactly how much just yet. Just going to go straight up. Going to have the upper diameter of the cylinder itself, again by an amount. Come straight down, because I want to have at least a little bit to the top before it then goes down into the root, and place it in something like that. Now, to finish off this curvature to the component itself, I might have just a little bit of an edge going in on the end of it over here, which will be variable later on down the line, but I want to have the option for just having a straight edge over there. And then I'm going to use the new blend curve tool available to us, just to be able to connect those two lines together. This was going to connect any two lines with a curve. So you select one half and then the other half, and you've got the ability to then go and place both of those in. So just by selecting the nodes at the end of that line, I can come in and adjust the intensity of that if I wanted to. But otherwise, as these lines move up and down, those will continue to be tangential to the vertical and horizontal lines respectively, and allowing us to then keep that nice and neatly in line with itself. Again, the next step over is we want to create the geometry of the blade as well. So using the same line tool, I'm just going to go off where that tooth starts from. I want to have that set as my blade height from the bottom of the part up to this point over here. So I'm going to go and specify that this is later on down the line, this is going to be the blade height. So thinking more or less of what I want to add in later on down the line, but not adding too much detail at this particular point in time, just kind of eyeballing it as we go through. And same for this portion over here. I might want to have this for the outer extents of the blades themselves. That'll be an adjustable value later on down the line. I might also not want that linked to that node over there itself. I might want it a little bit further along, making sure it's not snapping to anything. So I'll go a little bit further along and place that down over there if I want those as two separate values. The next thing, again, just going to go and place in either a spline or a blend curve along the way. So if you want a blend curve, it's not quite going to work if I go between these 2 points now, because it's going to try and make sure that they are tangential once more. So what I might do is put some construction geometry in to begin to drive the angles of those as well. So by changing inside of the sketch palette to the construction line instead, construction line geometry won't be used in the formation of solid geometry later on. So when we do convert the sketch into solid geometry, the tool will completely ignore any lines that are using the construction line type as a tool within the environment. So I'm going to use those two construction lines just to drive the angle. You can see that those are using constraints, a series of perpendicular constraints, ensuring that this line is always going to be horizontal, and this line over here is always going to be vertical, again with a series of perpendicular constraints, which we can see highlighted to us in the corners over there. If you are ever wanting to add these constraints in, we'll have a look at some of the other constraints a little later on, but we've got the ability to add those perpendicular constraints, or if that constraint wasn't there, or if I wanted to remove a constraint, I can select the constraint and hit delete on my keyboard. It will then go and delete those constraints. And I could go, at the moment, that's able to just adjust to whatever it wants to. Same with this one. I could go and force these ones to be either vertical or horizontal by using the horizontal vertical constraint and applying that against each of those two, for those of you that don't potentially know that. So using the blend curve, I'll just go and connect that line once more to this one. And currently it's a construction line once more, but I can convert a construction line to a solid line by selecting it. And in the sketch palette, disabling the construction line type against it. Therefore, we've got two closed profiles inside of the sketch as it stands. So we can convert an existing solid line to a construction line, and we can convert the construction line into a solid line if we ever needed to. The last thing I want to do very quickly on here is just close off this shape, just in case I need to later on down the line. So I'm going to go from my endpoint over here, horizontally across, disabling construction line, and coming down to somewhere in line with that, just in case I need this last closed profile later on down the line to cut any geometry that is unnecessary. The hope is I won't need to use it, but we'll just have it there for in case a little later on. Could always come back and add that in later on if we ever wanted to as well. Last thing I will do, just for the sake of demonstrating it, for those again that don't potentially know this, if I add a line in here, right at the origin, right in the center of the part, and go straight down or straight up, doesn't really matter as long as it's there and it's vertical, I can convert that solid line into a center line. And when using dimensions, we can use center lines to determine diameters on either side of the center line if we needed to. So just as a sake of an example, I'll go and create a sketch dimension between my center line and this vertical line over here. And rather than giving us the distance between those 2 points, it will give us a diameter. The other benefit, which is why I'm wanting to use this one at this point in time, is now that I'm happy with the sketch, I can hit Finish Sketch. And because the type of geometry I'm wanting to create at this point in time is a revolve, Fusion will automatically detect that center line for me, because it's the only center line available in the part at the moment on an unused sketch. And it will then automatically go and grab that as the axes of rotation for my revolve. So we can begin to add those in. It's an extra click somewhere further back, but it might be able to save you some time later on down the line as well, especially if you aren't wanting your revolve centered around the origin, or you're wanting to define a separate center line elsewhere. In this case, we could use the origin for our axes, but just to point that out as well. And then the profile that we want to use, again, we're just creating this for the tooth for now. I want to go and grab, sorry, not the tooth, the root. We want to go and grab that profile and be able to sweep that around. So using the revolve, we've then gone and created the profile nice and neatly on there, hit OK, and we've now got the base for our component. We can then later on, by adding parameters, worry about the shape, size, and height along the way as well. Once we've got that one set, the next thing we want to do now is actually start to be able to add the blades on. So with those blades, we want to be able to take a profile and pull it up along a certain height, or to a certain height rather, and be able to have some rotation to it. Now, there are multiple ways we could approach this. We could use a sweep. We could put a path that we want to sweep our profile along and have it sweep into the component itself. Or we could use a loft. You might have seen a loft before, where we can combine multiple different profiles and be able to have that profile go all the way into the component once more. But for the sake of keeping the blade thickness uniform throughout, what we've found with this particular model at least is that using a surface instead, and then thickening that surface, that gives a better result when it comes to anything that requires a uniform thickness. If we try and take a profile and sweep it along, yes, we do have the ability to sweep it along a path, but it doesn't always keep the profile with the required thickness throughout. So what I'll do is I'll create another 2D sketch. At this time, I'm going to use the ground plane to locate the starting point of my surface. And then from that point, I'm going to go from the origin. I want to make sure that my blades are always aligned to the origin itself. And I'm going to go straight down by an amount. At the moment, again, I'm going to go more or less the full length. Again, later on down the line, we can always use our parameters to drive this a bit better. But for the sake of this particular line, I'm just going to go straight down by an amount. And I'm going to convert this one, because I want this one to always remain vertical. I'm going to convert this one to my construction line. And I'm going to use this as a driver for the angle of my blades. If at any point in time I want to be able to have the blades move position around the circumference of the component itself, we can then use this as a point that's always going to remain vertical. And therefore we can draw another line, something like that, and dimension between those two. So I'm going to dimension between those two lines, the construction line and the solid line, which will be the actual surface driving line along the way. And I'm going to set this, at least for now, at 10 degrees. Because the component that we want to create is going to have the splitter, or at least will have the option for this splitter blade as well, I'm going to create a second line just to the side of that. So I'm going to go and create a line, and for the time being, I'm going to pull this out to somewhere along there and give this the angular difference of 45 degrees. So 45 degrees between our main blade and the splitter blade, which would then ensure that we've got the ability to go to 4 blades potentially. This splitter blade will obviously always want to have halfway between the two, and later on down the line, when we are looking at creating parameters, we can begin to push those as well. Now that I'm happy with those two, I'll then go and hit Finish Sketch. And we can go and begin to use the surface modeling to finish this off. The last thing I do need to make in this model is going to need to be a path for the sweep to follow along. At the moment, we don't have a path for it to follow, and that path I'm going to set right on the origin itself. So I'll create one final sketch, and that's going to be on the origin plane itself, the same plane, or the front plane at least, the same plane that we created the original sketch on. I'm just going to create a line that goes all the way straight up to the height of my blades themselves. I'm going to make two separate lines, one for the main blade and one for the splitter blade as well. So I'm going to make a slightly smaller one over here, and going to use the two of them separately. So now that I've got those two as a guide, I'm going to go over to my Surface tab. Inside of Fusion, we've got different types of modeling available to us within the design workspace. Some of you might only be familiar with the solid. We've also got surface, mesh, sheet metal, plastic, and so on available to us as well. Now for this one, I'm going to go over to the Surface Modeling tab and be able to create a single surface rather than a 3D component, or rather than a solid object. Again, just to make sure that we've got the uniformity to this. And in the Create drop-down, I'm going to go and grab the Sweep tool, which is also in my toolbar at the top. But I'm going to go and grab the Sweep tool, which is going to create a swept surface. And I'm going to use the single edge of this longer or wider line. And as my path, I'm going to use the longer of the two lines once more. And you can see it's just going to do a single surface with a infinitely small volume to it. So it's just a single plane that we're essentially creating at this point in time. And this is what we're going to be using to drive the overall component. We've got the ability as well to go and create a twist angle, so how much we want to twist this by as we go from the start position to the end. If we do 360 degrees, it's going to do a full rotation anti-clockwise around the component. We want to go clockwise, so we can drop that down to a negative value and it'll then go anti-clockwise around. And I don't want it to go full 360 degrees, I only want it to go 90 degrees. I want the bottom of the tooth to the blade rather to start where the previous one will end. So if we do create 4 of these around the component itself, I want the start of the one to end to begin above the end of the other one essentially. So once I'm happy with that, I'll hit OK on there. And then I'll just repeat the process for the second one. So using the sweep tool once more, I'm going to go enable the sketch visibility against both of those two sketches we created, selecting the profile 1 for these, the driver of the geometry, and then the third sketch line, the shorter of the two, as the driver of the direction for my line. Now this one's slightly different because we need to rotate it by slightly less than the same 90 degrees. If we do 90 degrees or negative 90 degrees again in this case, it's going to end a little bit further along than what we need it to. Just based on the height of the component itself. It's from start to end. So later on down the line again, we're going to need to work out a ratio between the start and end point for that. But for now, I'm just going to leave this at this. Maybe multiply this by 0.7 just to give it about 70%. So to multiply, I can just type in the parameters times by 0.7, and that'll then finish. For now, more or less where we want. We can always go in and adjust these values later on. Nice. So once we've got those set, the next thing we want to do is go in and thicken these two surfaces. So because I've started this surface right at the bottom, I want to go and thicken towards the top of the part, just so that I'm not going below the bottom of the part itself. And to do that, I can again go into the Create From the surfaces section, we've got the ability to thicken any surface inside of Fusion. So using the thicken, we're going to be creating solid geometry during the process. So using this one over here, using that surface, I'm going to go in the opposite direction by an amount. In this case, it's going to be about 2 millimeters, negative 2 millimeters. And I'll hit OK on there to create one solid. It's going to be created as a new body for now. Actually, I can probably make this as a solid. So I'm actually going to join this one, in this case, to the original. So new body will just create its own single body, which will be able to be edited on its own. By joining it, anything I do to this component might include the root itself. I'll do the same. I'll repeat the process on the smaller of the two blades by going -2. Again, we can turn this into a parameter later on. Now I can see that shorter blade, though it is a smaller one, I might not necessarily want it to be narrower. I might want it to be the same full length. But that's easily adjustable now. All we need to do is edit the parent geometry, in this case the line, and any adjustments I make to that line now will be done against the surface. So we can again start to go in and drive those values based on some parameters. We can add parameters to those and link those together as we go through. So just to prove that quickly, I'll go straight into the sketch itself that is being used to drive this. We always want the blades to go up to the end, or at least the creation of the surfaces of the blades always want to go up to the edge of the component itself. So to do that, I'm going to, first of all, to drive that position, I want to be able to look at the external surface of the component itself and add that into this current sketch. So I'm going to use the project geometry tool, which can be found under the create panel, project include project, or by tapping P on my keyboard, I can grab the project geometry tool. I'm going to go and project the external edge of the existing component onto my current sketch. I can either do that by specified entities or an entire body. I just wanted the specified entity. I'll hit OK. It's going to create a projection link. And so anytime that geometry adjusts, so will my geometry on the sketch. I can then drag and drop each of those endpoints onto the geometry itself, and it'll create a coincident constraint between the outer geometry and the endpoint itself. Therefore, wherever the geometry moves, the point moves as well. I could do that manually also within the constraints panel. I can go and grab the coincident constraint, create a coincident constraint between the endpoint of that line and the outer edge of the part. And if I wanted to, I could do the same on that one. Once I'm happy with that, once more, I can hit finish sketch, and those will be set. To test that even further, I could go straight back into my original sketch, adjust the location, I guess the diameter of the component itself, hit finish sketch, and we should see that that's now wider. And not only is it just wider on the original component, but it's also wider on the blades as well. So we've got that link between the two. The next thing I want to do, just to get these blades, the correct number of blades around, we want to then go in back to the solid geometry tab. We could do this from within the create if we want, within the surface if we want to, but I'm going to go and grab it from the solid modeling side of things. In the create drop down, we have the ability to create patterns of 3D objects. So in this case, we'll go into the pattern panel and grab a circular pattern. And the components that we want to create a pattern of are going to be each of these blades respectively. Now, for the sake of this side of things, I want to be able to pattern all of them. Later on down the line, we might establish that actually we want to have some configurations of a splitter blade or without a splitter blade in our creation. But for now, we're going to go and choose both blades as part of this process. But you'll notice, because I've set the original surface and thicken creation to join, at the moment it's looking for an individual body to be able to pattern rather than a single object. But what we can do is we can change the object type that we're patterning to a feature rather than a body, and therefore I can go and grab each of these two thickens respectively, and it's going to grab both of them at the same time. The axes of rotation is going to be the same axes that we've been using up until now, which is the origin. So I could go and grab the origin itself, I could go and grab the line that was used to revolve it, or I could use any cylindrical reference that has the same center point as the component itself that I'm wanting to revolve around. And then it's going to ask me how many instances of this pattern do I want. At the moment there are 3. I can bump that up to whatever value I want. In this case I probably want 4. Cool. And once I'm happy with that, I'll hit OK, and we've now got the blades going around the component itself. The last thing we want to do to finish this off nice and neatly is be able to then cut away the remaining geometry. So what we'll do then is use that same profile we created right in the beginning on the first sketch, and then use our combining functionality within Fusion to then combine 2 shapes together. To do that, we can do a revolve once more, but this time we're going to include the blade portion of the same sketch. So using my revolve tool once more, the same tool that we used in the beginning, we're then going to look at that exact same sketch once more, and using the axes, the original axes that was inside of that profile, we're going to go and grab, so within the sketch itself, we're going to go and grab the original profile plus the blades, holding down Control or Shift. There we go. And then rather than cutting, which is the default, anytime Fusion goes from between 2 objects with a new creation, a new solid creation, anytime Fusion creates a new solid and that intersects any other solid, it defaults to cut, because usually that's what we're wanting to do. But in this case, we're going to change the operation type, which changes how it views that rotation or that revolve. And rather than cutting, we're going to use intersect. And intersect is only going to leave behind anything that was intersected with the revolve that we're creating. Basically then the opposite of our cut. So rather than cutting away any geometry that is in the firing line, I guess, we want to go and cut and leave that behind in this case. So I'll hit OK on there now, and we should now have our profile nice and neatly set. Doesn't quite look yet like this one does. Ours is a little bit short and stubby for now, but we've got essentially the makeup that we need to as we go through the rest. Now essentially what we can do is start to use that same sketch to get a good understanding and a good drive for where each of those components are located and how big they are, how small they are, widths and so on. So using that same sketch that we've been driving up until now, we don't have to go straight into the sketch to edit it, although most of the time it's recommended. We can start to adjust the sketch directly from the 3D modeling environment. So I can go and drag that up, and you can see by dragging that line up, the 3D model itself is pulled up as well. By dragging the top of the blade up, I can go and bring this all the way up there, and we can see that that's also going straight up. I'm going to drag and drop that directly on the top face over there, just so that it creates that constraint between the two. It's always going to move up with the top of the sketch itself, and therefore we've always got a line that is vertical, and that blended path is always going to come straight down from there. This one doesn't seem to be updating all that much, and the reason for that will be the line that is driving the original sweep itself. So if I pull that sweep all the way up, potentially all the way to the top, although I don't necessarily want it to be all the way up to the top, but if I bring it a little bit higher up, we're going to have that driving as well a little later on. But you can see by changing that, we can get a slightly sharper incline towards the end of our part, just by adjusting the frequency of that. We can do a similar thing with the smaller of the two blades. We can drag that up a little bit, and we should start to see the splitter blade do the same thing. If I pull this out a little bit further, again, I should start to see the blades go out. I'm going to go and drive that construction line all the way to the end until the outer extents of my part. And then that way I can come in and adjust not only the diameter of the root, but then also the diameter of the blades, and even the height and thickness of those blades as well. So if I want to make it slightly longer, slightly shorter, we've got a fully adaptive model now that we can begin to work with. And that's essentially the basis of what we want to do inside of this. Yes, we've got a few components that fit together a little bit in a bit of a messy way, but for now, this is essentially what we're wanting to make use of in terms of the creation of the component. Once we then start to add a bit more detailing, we can come in and add some filleting just to neaten the corners off to make it a bit more manufacturable. We can start to add parameters and toggles and that to switch between those two. The other part that we want to make, which can be a lot heavier in detail, is going to be the encasing itself. If we have a look at the way we've gone in and created this one, we've got a single sketch that drives the core of the component itself, the core profile of the component, and then we've got a secondary sketch that's going to drive the cone. So as it's pulling the air in from the top and distributing that out, we've got a cone that's going to need to be created as well. And then on top of that, to combine the two shapes together to get the input, push it out to the output, we've also then got a loft that is connecting the two together, and that's going to be using a single round a diameter that we want to be able to specify. That's then going to go into a conical shape while revolving around itself. So we want to be able to create all of that geometry as part of this process. So I'm going to go and create a brand new component, again using the plus icon to create a brand new design. Once more, we're going to start with a 2D sketch. This time we're going to be on the ground plane to try and get the layout of the output nice and clean to begin with. So I'm going to go and place my 2D sketch right on the top, looking at the top down, and using a center diameter circle, I'm going to first of all specify the radius that I want for the housing itself, for where the impeller itself is going to sit. So I'm going to say I want it more or less. I'm not, again, going to worry too much about sizing on this one, but I'm going to say it's going to be more or less 90 mil, maybe 95 or so. So I'm going to place it somewhere like that. I then also know that I want to have a bit of a gap from there to the center of the channel that the output is going to be located at. We want to then have that push out. So we're going to have a little bit of a lip, and as the cone comes out from there, it's going to have a little bit of an offset as well. So it's going to go out. So we've got that at about 90. Let's go around 130 or so for now, and place this one right over there. I'm going to go and change this line to a construction line so that it isn't taken into consideration during the creation of any solid geometry later on down the line. And then we're going to go in and start to establish as a final location. We want to go straight out from there, rather using a line tool than the circle tool. I'm going to go straight out from there to that point. Again, as a construction line, just to get a point in space that we can begin to take a look at. And the way we're going to do this is try and reverse calculate the starting point and the center position of the output itself. So because we want to be able to drive how wide the diameter is at the output, and everything else follows in from there, we want to first of all go and specify where that output point will be located, and then the rest essentially will follow from there. So if we know that we've got a diameter of around 50 mil, we then want around about 25 mil line at this particular point in time. Hopefully it makes sense for now, but essentially what we're doing is we're going into the sketch over here and creating this line to specify the center of the diameter of the output. So if I go out of the sketch very quickly and toggle that first sketch on, we've got the center of the cone itself right over there. And because we want to reverse calculate that, we need that point first, and everything else will essentially follow from that. Cool. So what we want to do then is come into our create panel, and we're going to try and create a spiral from the start point over here and slowly work its way out to this point over there. So we're going to go into the create panel and grab an arc tool, and then we're going to go and grab a center point arc. And because we know that we want the arc to be slightly larger than the radius of the driving line for now, we're going to start our center line arc. And we also, want it to be tangent to the center line arc, to the center line of the channel itself. So I'm going to go off to the side over here very quickly. By an amount, I'm not too worried yet about the amount, but I'm going to go and place this point over there to start off with, and I'm going to end vertically in line with the center itself, somewhere over there. I then want another arc that's slightly longer than the original arc, so I'm going to go off ever so slightly over there, place that point over there, and go again another 90 or so degrees. And I'm just going to repeat that process until I have an arc that will be in line with this. So I'm going to then go and drag those 2 points so that they're coincidental with each other, the end point of the arc and the end point of my line. And then I'm also going to ensure that these arcs are always in their correct position. So I'm going to use the vertical and horizontal constraint between the center point of each arc and their end point. So grabbing this line, this point over there, I'm going to go and align these two vertically. This one over here, I'm going to align vertically, as well as these two over here. Then repeat the process, this one to that one to that one, this one to that one. So vertically aligned, horizontally aligned, vertically aligned, horizontally in line. And that way, as we adjust the one, it should start adjusting the others as we go through, more or less. But it is keeping those in position as we go through. At that point, we can then start to establish the ratio between each of these components, right? So we can go and say that we want to dimension. Again, I'm not going to worry too much about the exact value between these two, but I'm going to go and say these two are, for now, set to 15 millimeters. We then want to go and take the remainders and halve that each time. So I'm going to go and take the distance between these two and say it needs to be equal to whatever value this one is divided by 2. Then I'm going to repeat the process over here between these two and say that needs to be divided by 2. And then lastly, this one to that one, which is equal to that one divided by 2. That way we tend to get a really nice curvature to those, ensuring again that these are all going to be tangential to each other whilst increasing the radius. And you can decide on the ratio that you want. Again, we can add parametrics in there to make those a bit better. But now by driving those, you can see how it's able to establish the shape and size of these components for us. By driving the radius or the diameter of this center line, we then also get to drive each of those. So if either of those begin to adjust, they'll start to push each other to various distances. We can then also begin to dimension between these 2 points using that line over there. And you can see that as soon as I start to drive that, if I say for now, I want that to be 25 millimeters, it doesn't quite like that one, a little bit over constrained. I'll just go and delete that one. Actually, rather than deleting, what we can do is we can toggle driven. So rather than this one being the driving dimension, I'm going to toggle its driven. And I'm going to make sure that this one is the driving dimension. See if that fixes the issue quickly. There we go. and now the rest of them are all going to be driving. So from there, we've got a nice way of being able to drive all of that. It's a long, fun way of getting to that point. So just bearing in mind that this 25 millimeters, that's predominantly the sketch done for now. I'm going to go and hit finish sketch, and then we can always add a bit more detail to this a little later on. We then want to go in and create a circular shape on this profile over here that we're then going to sweep down to nothing all the way at the end of that line. So again, using a 2D sketch on there, I'm going to go and create a sketch on the origin, which is in line with the end of that spiral. Otherwise, we could create a construction plane instead on the plane along path, so we can use that path to make sure that we've got a sketch on that path, and begin to create a sketch on there, or a plane on the path that we can create a sketch on. But in this case, it is neatly aligned to there, so I'm just going to make use of the fact that it is already there. So I'm going to create a sketch on the plane that is intersected by that line, and using that same project geometry tool to get the center point of my spiral, I'm going to use the P button, grab the center point of that spiral, hit OK, and I've now got a referenceable point in the center of that component. I'll then go in and create a circle indicating the diameter of the part, which, if we make it 50, will be exactly in line with that point over there, which tends to cause a bit of an issue with our sweeps or our lofts. So I'm not going to go exactly that much. I'm going to go maybe about 45 to begin with, which again we can adjust later on when we are starting to look at the parameters around the model itself. Again, this is just conceptual phase for now. We can begin to work on the actual full-on dimensions a little later on. So with that set, we can then go and use the loft tool to create the spiral down as we go through. So using the create drop down, we have the ability to go and grab the loft tool. Now the loft tool will allow us to create a solid object between successive profiles, or by going from one profile to another, or from one profile to nothing. In this case, that's essentially what we want to do. So along the length of the spiral, we want to go from whatever diameter the output is to essentially nothing, therefore dividing the distribution of that profile along the length of the path itself. So the profile I want to go and grab, in this case, as we can see over here, is going to be that profile as our first point. And my second point, therefore the end of the component, I want it to just go straight to that point over there. Now it's going to complain at the moment that they are coplanar, which is correct because they are right against each other, and therefore we need to guide it along a path along the way. So we're going to use our guide type as a center line. The center line is going to make sure that as it goes around here, the center of the shape is always going to be around this line itself. So using my plus symbol, I'm going to go and grab this entire center line over there, and we can now see the conical shape as it goes and brings itself all the way to the end, again evenly distributing that displacement of, in this case I guess, air. Once I hit OK on there, now we've now got a shape that we can begin to make use of for either adding geometry or subtracting geometry a little later on down the line. If we then go and repeat that process, because we're going to want to have a shell to this, we've got the ability to go in and in the same sketch, so in our second sketch over here, I might go and create another shape that's slightly larger. Again, not 50, but maybe 48 or so. We'll adjust these later with parameters, but slightly larger than that. And then a similar process on a second sketch down here. So using the create 2D sketch once more, I'm going to go and grab another sketch on the same plane, but it needs to be a separate sketch for this one. Again, I'm going to project the geometry of that point onto my sketch and create a circle that's going to be about 2 mil or so for now, whatever the thickness of my wall is that I want. And I'm going to go and repeat the process of creating that loft, essentially creating 2 lofts as part of this process, one for the shell and one for the subtractive process a little later on. So using the same 2 sketches, I'm going to go and grab that one over there, the entire profile, up to this one over here, and hope there isn't an overlap. There should be a slight gap, hopefully, if I've done this right, between those 2. And then I should also have the ability to add a path in there. There was a slight overlap between the 2 profiles, and it will struggle a bit if there is an overlap, because it's trying to calculate surfacing and it can't be intersecting itself along the way. So I'm just going to go back into this sketch over here and reduce that down to 47. That should be just enough to then complete that process using a loft from this shape to that shape using the center line in sketch 1. We should now have a secondary shape that we can come in and add. So I'm going to add this rather than a cut. I'm going to add this as a brand new body and hit OK on there now. So I've got 2 bodies inside of this model, keeping them separate for now. We'll merge them a little later on, but we've got the first body, which is our conical subtract, and then we've got our conical shell. So just by doing 2 single clicks or a click with a bit of a gap and then another click, we've got the ability to rename components. Otherwise, we can also right click on a body or any feature that exists inside of the model, and we've got the ability to rename it from inside there. Once we're happy with that, we then want to go and finish off the rest of the component, right? So using the same 2D sketch that we've used up until now to drive the outside of the component, we want to have the main body created at this point in time as well. So we've got essentially what we want to do as part of this process is create I guess a bit of an arc around the outside of the part. So if I have a look again at the original sketch that we've used as a guide for this one, we've got that center line working its way all the way out from here into that point over there, the spiral itself. But then from that point, we've essentially got the outer perimeter of the component once the loft has been created all the way around. And that reaches about this point over there and goes all the way up to that point. But we've also got a cylindrical shape that's going to pick up the extents of the bottom half. So essentially we're breaking this up into 2 different arcs or semicircles rather. The top half is going to take into consideration the extents of the overall loft with its own center point in line with that, and the second half is going to be centered around the origin itself, and essentially just using the extents of the center line as a guide, just to make sure that the overall shape, again, this can be any combination of geometry, but we essentially just want to have enough space around there in a logical, semi-logical way. Hopefully that makes sense. So the first thing I want to do now is quickly go and create another arc. So I'm going to go and create another center point arc for the lower half. So that's going to use the same center point as the origin. I'm going to go from the center line of the part all the way up to a point 180 degrees around. The other point is going to then continue the same line equidistant, so using a construction line once more, so it's not used in 3D geometry later on. I want to make sure that this line is going to be equal to this 25mm line that's currently there. So I can use, again, a constraint, an equals constraint this time, to make sure that the 2 lines are equal to each other in length. And then that way, if that line gets longer or shorter, this will then continue to adjust. So I can go and create another arc another center point arc on this line somewhere. I'm not too worried just yet where it's located, but I'm going to have its start point over there and its end point somewhere there. And then I'm going to make sure that those 2 points are aligned to each other, which does adjust the center point of that line. But because that center point is now associated to this horizontal line, they're always going to be horizontally in line with each other. Hopefully that makes sense, but that's essentially what we're wanting to do for now. And the other adjustment we might want to make, just to make sure that this is nice and neatly tailed off at the bottom over here, is I'm going to go from this midpoint over here, which is going to be right at the tangential point of the bottom of our part. I'm going to go straight out from there, in line with the end of the component itself. So something like that, and then finish that off nice and neatly over there. From there, last thing I want to do is then just go and trim this down. So using the trim tool, I'm going to go and trim this line and that line. Now that might mean that I've got an adjustment to this over here, which I don't actually want. But what I can do is I could go and create a dimensional, again, a driven constraint or a driven dimension between those 2 points. And do the exact same thing down here. I've got a few different ways I can go about that. Either, again, a construction line between those 2 points and make sure that they're equal to each other, or using this method, I can then say that this is going to need to be a driven value. And so whatever value this becomes, the other one becomes as well, making sure that those two are always associated to each other. Cool. Hopefully that's making sense so far. So we've got our spiral that's all nice and neatly set in there, and that spiral is driving the loft. We then want to make sure that whatever the diameter of the loft is, that the outer perimeter of the part is always in line with it later on down the line, and hence we've got these 2 semicircles over here. We've then got a closed profile between those 2 points, which I'm just going to close off with a solid line. Again, I suppose as an indicator on this one, you can see up until now, the only solid element is the inside circle over here. It's got the shading in blue on the component itself. But if I close this off, at the moment, it's got a construction line between those 2 points. If I close this off with a solid line, I should see the entire inner perimeter solidify now, which is exactly what I'm wanting at this point in time. So I'm going to hit finish sketch on there now. And this should give us now the ability to create geometry and start to thicken that component for the housing itself to sit inside of. So I'm going to use the extrude tool to then go and extrude the entire perimeter of the shape in 2 directions. So rather than just going up in one direction, I want this the center plane to be right in the center of the cutout, because that's essentially where I wanted to split that later on, right at the origin plane itself. So I'm going to go in 2 different directions with 2 different values. So to begin with, I'm going to use that same profile, and rather than going up in one direction, I want to say that the extent is, the direction rather, is going to be 2 sides. It's not going to be symmetric. I want to have slightly more material to the bottom than to the top, so it's going to be 2 sides instead. And therefore I can drive each side independent of the other. So I'm going up by 5 millimeters, and I'll go down by about 10. And rather than cutting, I want this as a new body. I want this about 10 to begin with, and we can adjust later on down the line as well. This doesn't line up perfectly just yet, but that's just because I've kind of guesstimated things at the moment. Again, using parameters later on down the line, we'll rectify all of those, but we're just trying to get things more or less in location for now. So new body, hit OK on there, and that should be that. And then the last element of this that I want to create is the cone itself. So as the air comes in or out, depending which way we're wanting to propel it, we want to have a cone that's pushing or pulling air in from the top over here. But the profile of that isn't too dissimilar from the profile that we created for the spline. It's pretty much the same, bar a few extra elements to it. Those extra elements are going to be the way we push the air out essentially from there. So we're going to go and create another 2D sketch on the front plane once more, just to keep everything aligned to itself. And just again, to analyze this a bit better, we're going to go and just sketch it out to begin with and then start to bring the different elements back together. So if we ever are creating geometry or a sketch inside of any objects, we might want to go in and slice the geometry that we currently that's currently in the way. In this case, we've got a sketch plane that's right in the middle of the part itself. So we can, in the sketch palette, just slice the graphics, and that's going to bring us right to the sketch plane itself and slice up anything that might be in the way, giving us a section view as we go through here. From here, we can then go in and once more create the center line that's going to be revolving around our component. So I'm going to go straight up a little bit below. I don't want the part sitting right on the horizontal line. That's the horizontal, or the origin, is where I want my split to be later on. So for the sake of this one, I want to go a little bit lower down. And then I'm going to go straight up by whatever the amount is that I want the height of my propeller to be, or that needs to sit inside of this. And we're going to do a similar process again where we go straight out from there. We then go up. We'll have a blended curve somewhere along there, and then we'll do a similar thing where we've got the external perimeter. We don't have to worry this time, at least, about the cylinder itself. We just need to worry about the blade sizes, at least for this case, and then where the cone itself starts, where the blended curve starts. So again, I'm going to go straight out externally, create it as a construction line, and then going to blend curve between those 2 points. So go between there and there. So we've now got the shape, the void that we want inside. Again, we're going to use parameters to worry about the sizing and shape of all of that a bit better later on down the line. But we've got, again, the rough shape that we want for this particular process. We then want to offset this ever so slightly by whatever thickness we want, whatever our nominal thickness is along the component itself. And to do so, we can use the offset tool inside of our modify panel, whereby we can either offset an entire closed perimeter or an entire chained perimeter, or we can use a single, by deselecting chain selection, it will then select a single edge at a time. So I'm going to go and do that towards the outside, and I've established that I probably want about a 2 mm thickness, at least for now, for the shell itself. So something like that should be good. And then if any of this geometry ever changes, the offset should change to adapt with it. We then want to close that shape off as well on either end. And then that is set nice and neatly from there. But that's not all we have to this, obviously. As we've seen before, we also have, so we've got not only the diameter of the part itself, or the diameter rather of the spindle in the original sketch, but we've also got a offset. If I drag this out a bit further, we've also got an offset that we want for a channel to push the air straight out from there. And that we essentially want to be equal to a certain value, and this is going to be the height of the blades themselves. So we want to, since we're going to be using this inner profile over here as a cut, as a void, we want to be able to then cut out the void that we want for the air to disperse as well. So inside of the same sketch, we want to include a little bit of geometry that's going to go all the way up to a particular point over here. And that's going to act as the void that's going to cut through the channel and ensure that it's going to go all the way up to the center line, at least to begin with, until it can intersect the cone of the void itself. And it's going to be able to then go and intersect all the way up to at least that point over there. Again, I'm eyeballing this for now, but with dimensions later on down the line, we can ensure that that's there. And I essentially want this channel to be equidistant on either side of my origin point. So from this angle over here, if, for example, I set that this edge over here needed to be, or the thickness of that channel needed to be 3 mm, I want that to be half on the top of the origin and half on the bottom of the origin. So I can just go and grab the end point, the origin itself, and then the end point of that line, and I can say that that always needs to be equal to that value divided by 2. Again, parameters later on down the line, we can adjust that as well. That's decided to throw itself off a cliff. So we're just going to go that way around and ensure that this line itself is always going to be vertical. That should fix that a little bit. And if we really wanted to, we could probably project this point over here using projected geometry over there and align that to the projected geometry. If I've kept the projected geometry on, let me try that one more time, hit OK, that will keep it there. And using a coincident constraint, I can create a coincident constraint between that line and that point over there, and this will always be in line with that point. So if that point ever moves, which it will, we've got a profile that we can make use of along the way. The other thing might be that this thickness we always want to be equal to or come up to that surface over there, and we can play around with those again a little later on with parameters. But lastly, I'll hit finish sketch just to drive this home now. We're going to go and close that profile off. So using a revolve once more, I'm going to go and grab this profile, which is going to be the surface, and the axis is going to be there. We're going to create this as a new body once more. Using the same sketch, create another revolve around this body, also as a new body for now. We can then go and ascertain which body is which once more by renaming each of these. So this is going to be the enclosure body, or let's call it the enclosure body. We're going to have the shell, so the cone shell. We're going to have the cone subtract. And then we essentially want to go and merge anything that's going to be subtracted together, and anything that's going to remain behind needs to be a single body as well. So using our combine tool, which is available in the modify panel, using the combine tool, I'm going to go and say, well, my cone subtract, my conical subtract, and my cone subtract, I want as the same body. I just noticed an error that I've made over there. I'm just going to go and say that I want these two, they're not going to be able to join if they're not making contact with each other. So if I hit OK here, I should get an error, which I didn't, surprisingly. But what I do want to do is make sure that that is connected. So just rectify this one very quickly to include that over there. And then this combine, I want to combine. Let's try that one more time. Delete this one very quickly. Use the combine tool to combine the sub and the cone. Try that one more time. Wrong one. Try this again. There we go. And that one. Combine the two together, so they are now one body. If I toggle visibility of everything else off and just that one on, I should see that they are one body, which they are not currently. I've got the two shells connected. Apologies, let me edit that one more time. Must have selected the wrong one. You probably saw that. That is the subtract, and I want to combine that subtract. And that's a slight issue that we have where the reason we're having this issue is because if I toggle the visibility of the shell element off, this cone over here is merging to nothing, and essentially because that's basically an infinite point, an infinitely small point, it's just struggling to grab those 2 points over there. So what we do want to do is, rather than having that as it is over there, we might want to extend in that sketch that we created over here, rather than those 2 points being coincidental with each other. I'm going to delete that point and just move this line ever so slightly along, if it will let me. Otherwise I'll just delete that line and make sure that it's ever so slightly further along than that point over there. Might be 0.5 mil or 0.1 of a mil or something like that. So I'm going to dimension between that point and here. And I'm going to say it's going to be 0.1 of a mil. That way the cone itself starts, and it won't be very long after that where it then becomes its own geometry. And that way around, with the conical shell there, which isn't the one I wanted. I'm going to re-attempt this one. So that once more we can use the combine tool and grab the subtraction conical and the subtraction cone, and you can see those two merged together are happier this time around. So if I toggle visibility of these ones off, we should now have this as a single component, or a single body rather, which is the subtracted area that we want, with the thickness of the channel and the output, as well as the rest of the components, which we then want to go and merge into one other final component using the combine tool. I'll go and grab the conical shell, the enclosure body, and the cone shell as a single join body. I can go and rename those as well if I wanted to, but I've now got a solid component down here and another solid component over here. And then with the final combine, I want to take the volume of my conical subtraction and take it away from the shell as well. So final combine is taking those two shapes and saying my target body is going to be the shell, and my tool body is going to be the subtraction, and I'm going to subtract the one from the other. Might have a few seconds to think about that, but we've now got, again, not parametric yet, but we've got pretty much the shape that we're wanting along the way. We'll come in later on and fill this in a bit better, but we've got an external shape that has most of the componentry that we want in here, and we can use a very quick section analysis to have a look at that and see that there is in fact a channel all the way through. And as we rotate this channel around using the dials on here, we can see that that has a nice gap all the way through the component. And that's essentially what we want to show for this portion of the video for episode 1. Again, the next episode, the next video we're going to be making is going to take a look at a bit more detail as to how we can start to make this a bit more parametric, looking at a few equations we can begin to look at to drive this a bit better. But this is still a pretty solid component that we can make adjustments to widths and heights and so on if we needed to as well throughout the creation of this, just using sketches and a few small parameters along the way without using any equations really from within there. So thank you very much for your time. I know this one's going to be a bit of a longer one. Hopefully it's still been enjoyable, and we'll see you guys again in the next video. Thank you for now. Goodbye.